Let's now see a mechanism for the reaction of carboxylic acids with thionyl chloride in order to give carboxylic acid chloride. Let's draw the structure, the general structure for carboxylic acids. This is general structure for carboxylic acids. This is thionyl chloride. Remember, the formula of thionyl chloride is SOCl2. This is a proper Lewis structure for it. 2 lone pairs on each of these oxygens of carboxylic acids. The question is, which of these is actually basic? So we can prove that separately, but for now, we can move a lone pair from this oxygen to make a double bond here, something like that. And obviously that carbon-oxygen double bond must be broken simultaneously. So the carbon-oxygen double bond broken, and then we make a bond between oxygen and sulfur, and the sulfur-oxygen double bond is now broken. Now, this is similar to nucleophilic acyl substitution reaction actually. So the sulfur-oxygen double bond is broken. It's all right to reform it in the same mechanistic step with simultaneous departure, if you like, of the leaving group, the chloride ion. So this is the intermediate that we now obtain. So this is the intermediate that we have obtained. We have also the chloride ion in addition to this. So the chloride ion is also present, which can behave as a base in this step to take off that proton. So we can show this with a K arrow. So we take an arrow from the chloride ion to that proton, and the hydrogen-oxygen bond then is broken, giving electrons or releasing electrons to the positively charged oxygen. So this is now the intermediate we get. This is the intermediate. We can assume then that another chloride ion comes in to attack that carbon of the carbonyl group. So we can do that. So this is the chloride ion. Chloride ion comes in, attacks that carbon. The carbon-oxygen double bond is broken. We can assume that we can reform it. So it's reformed, so it's broken and reformed. Mechanistically, this is acceptable. The carbon-oxygen single bond is broken to make a double bond here. All right, the sulfur-oxygen double bond is broken, it's reformed, and the chloride ion leaves. So that's also similar to nucleophilic acyl substitution reactions. The product that we get now is actually a carboxylic acid chloride, where the chloride ion in this case has formed a bond with that carbon of the carbonyl group. So this is the main product that we are looking for, which is the carboxylic acid chloride. And we have also, if you look carefully, there's a double bond here between oxygen and sulfur, and obviously the sulfur-oxygen double bond is retained. So there is sulfur dioxide as a byproduct, sulfur dioxide, plus obviously the chloride ion. So this is the main organic product, which is a carboxylic acid chloride plus sulfur dioxide plus the chloride ion. So this is an acceptable or satisfactory mechanism for the conversion of carboxylic acids into acid chlorides by employing thionyl chloride.